Again, my name is Micah Houtz, and I'm a senior engineer and PE here at Wunderlich-Malec. And I've had with me Chris Rowland, and he's a senior controls engineer. And
good afternoon, everyone.
Hi, Chris.
We work very closely together. We do a lot of solutions in the power industry with SCADA and automation. And I'd like to talk to you today about configurable load shed and event reporting. Let's go to the next slide, please.
Sorry, it's just taking a moment to update. There we go.
So what is electrical load shed? I think everybody probably knows that here in the US, we run a 60 hertz AC system. And so electrical motors and other loads have got to stay close to that 60 hertz to operate effectively. So an electrical load shed system's job is to keep the load on the system balanced with what the power production that's available in that system. Let's move to the next slide. So in this example, we've got a plant here with multiple generators, and it's designed to normally have a connection to the power grid. Now let's say we have a utility breaker trip. If we're already running at maximum output on our generators, we're gonna have to do something. We're gonna have to remove some electrical load. Could be a chiller or a water pump. So we've got to take action very quickly. Let's move to the next slide. And I'm gonna let Chris Rowland speak about this. So in our plant, I'd like to describe the fact that we've got multiple generators that use different prime movers. We've got gas turbines, we've got steam turbines, and we've got to balance the electrical load while also being able to meet the day-to-day operational constraints.
All right, thank you, Micah. So what we have here is a screen that we've developed for our custom load shed system. And what it provides is a very configurable interface for our operators. In the upper left, you'll see triggers. And what we mean by trigger are different events that would be loss of generation, such as the generators or the utility source. So for this particular system, it's selected to a loss of utility. And what the screen is showing is based on the loads that are enabled, it's selecting and showing you in real time what's going to actually be shed based on what the system is calculating needs to be shed to maintain a stable system. In addition to being able to enable and disable the loads, you can set the priorities for which loads get shed first. So if you take a look at the lower right corner, you'll see where everything's being calculated, such as what's available for your high priority loads, medium and low, and so forth. If you want to go on to the next slide, we'll show you what happens when an event happens. So here's our load shed reports, and just this little screen quickly shows that trigger one happened, the utility loss. It shows what was available and what was actually shed. The next screen will show the actual report. And one thing that our customers have told us that, they do have different load shed systems in place, and it often takes them a long time to figure out what happened, even if a load shed properly took place and they maintained their plant. So this report shows what was currently running in the plant as far as generators and utility coming into it. Down below, it shows what was selected to be load shed, that total load of 3,477. And on the next screen, it shows what was actually shed. So that's just an indication of the actual relays that were fired and tripped those loads. Now, one thing I want to talk about, the way we maintain this, you can imagine that you need to shed very quickly. So in the background in our control system, we're constantly calculating what needs to be shed, and we're sending, to get a little technical, a bit stream of zeros and ones of the outputs that need to be fired all the time. So when we actually see that trigger, like the utility breaker opens, those zeros and ones immediately get moved over to fire those relays and the shed event happens.
That's great. 5 minutes left.
Right. You want to move on to the next screen?
So look at that. I mean, with the system that Chris described, we've kept all the load running as much as we could, okay? So you might have lost a single pump, but the rest of the plant is 100% stable. And, you know, the operator can watch the plant and change those priorities on a day-to-day or seasonal basis. And they can see from that report that the system worked exactly as intended. And that gives them a quality document so they can verify the performance. So this is excellent for systems where you need 24/7 uptime of your electrical system. So, all right, we had that event. What happened to our utility cable coming into the plant? Let's look at the next slide. Yeah. So we have a system where we're going to gather oscillography records. And what that is, that's the records of how the relays saw the fault and triggered. And that's on a time synchronized system with an Ethernet backbone. Nowadays, we can do time synchronization over TCP/IP, which is great. And we're gonna grab those records from the relays, and we're gonna sort them by the timestamp and put them in a central location. So if we could look at the next slide. So you can see here, this is like a display that gives you the timeline of what happened. So you can see that red line over on the left, that could be our incoming feeder relay. So we see that event happening. And then the other lines a little later represent possibly our load shed trip of maybe our chiller or water pump. And you can zoom out and look at the overall operations on the electrical system. We can look at the next slide. So with that quick interface, which is just a very easy drill down, we can pull up the actual alternating current waveforms of that incoming feeder that tripped out. Well, look at that. We've got a high magnitude current there on phase A, and it looks like a single phase fault on our feeder coming into the plant. So you can imagine that's a very quick process. Your plant is kept running, you lost a load, and now you've identified that you can see that there was a phase fault on that feeder. Let's go to the next slide. So what we've talked about, as you can see, we've got a configurable load shed system. That's going to get your electrical system staying on. 100% uptime is the goal. And you can optimize that based on your plant operation, seasonal or daily, and operating priorities. And so we've minimized electrical outages to the maximum extent possible. And we've got operation reports that are going to allow you to quantify and verify that your system is operated exactly as intended. And then after you've done that, you can drill right down into the electrical oscillography reports from the protection relays. And they're all there right at your SCADA terminal. They're time-stamped, and they're quickly accessible for troubleshooting and correcting the problem. So it's really the ultimate system for a high uptime type of microgrid or industrial or utility electrical system.
That's great. So for a new customer who's come to you and said, yes, I want you to, I would like this technology, what's the timeline in terms of from that moment to having this up and running?
Well, Wunderlich-Malec really specializes in customized systems, okay? So what we're gonna do is work with our customer to determine the requirements. And we're going to go through a process of, in detail, drilling down to, how many loads, how flexible does it really need to be? Are there only 2 seasonal modes? Are there, more than that? And how far down into the electrical system do we need to go? So that timeline is really going to depend a lot on our customers' individual needs.
Is there a typical time, or is it just too varied?
Chris, what do you think? That's a tall order to throw out a time like that, but
Sure.
And not give you only 20 seconds.
If it's a fairly simple system, we could deploy it within probably a month.
That's great. Well, thank you both, Chris, Micah. I appreciate your time today, and I hope you have a great week.
Thank you.
Thanks.